Hello, I just realized I need to set up the screen. Give me just 1 second. Uh-huh. I forgot all the... All right. Hi, everybody. Give me 1 minute. All right, there we are. Hello, and welcome to another screencast. I'm Dave Robinson, and welcome to another screencast. We'll be using R and RStudio to analyze data I've never seen before. As usual, the data comes from the Tidy Tuesday project, a weekly data project in R run by the R for Data Science online learning community. And as always, I'm really excited to be broadcasting live because it's a great way for you to engage. If you're watching the screencast live, please feel free to comment. I'm able to see your comments. Please ask questions, give suggestions, analysis you might want to see, analysis you're wondering how I might go about doing it. It's one of my favorite parts of running these screencasts. So yeah, please feel free to chat, chime in, and let's see what we're analyzing today. It's crossword puzzles and clues. Actually, that's all I know about it. All I know in advance is it's crossword puzzles, cryptic crossword. Okay, so it's not I've never done a cryptic crossword. It's something like jumbles or whatever. Isn't it like a cryptograms? I don't know. Let's see. And what is Big Dave? Is that a dig at me? Well, let's see. All right. So I'm gonna head into R and use the let me see the Tidy Tuesday R. I use Tidy template. There we go. And set up today's Tidy Tuesday. So just Big Dave. Huh. Wonder what unknown TZUTC is. All right, let's try this. Let's see what it said. That doesn't work. I'm going to go ahead and, okay, I'm just going to start. I don't see what I did differently, but yeah, I'll start with this. And let's look, there's two data sets, Big Dave and the times. Let's see what those are. This just gives me documentation for Big Dave. Looks like it might be the same in the times. Yeah, both are the same format. Look at this. All right. That's not. The link here is does not. I don't think it is what they meant it to be. It's a Oregon spotted frog telemetry. This is not the data set. Oops. Well, at least not. All right. Then let's see. Cryptic crossword clues. Okay, I'm gonna start with the one in the times because I don't know what Big Dave is, but 214 and with 100,000 clues in the times. All right, let's try looking at some of these clues. So if I do like if I just view it, it looks like we have a row ID, acquisitive chap, covetous, and definition is acquisitive. What's interesting is, so I'm trying to figure out exactly what this is. There's a definition, there's a clue, and there's a chap as we see it. Man, I don't even understand what these mean. Let's try looking at an example, figure out what because I've never done a cryptic crossword, like I said. Acquisitive chap as we see it. Let's see. Stripping, unclothing, you. Man, where they? Man, I'm totally. Chap is cove, as we see it. Okay, so I think what it's meant to do is like, oh, okay. So I think I'm understanding this just a little bit better than I was just a second ago. Anyone else do cryptic cryptic crosswords? Because yeah, this is new to me. Stripping, unclothing, because it's U for uniform, then external letters of kernel, holding. Let me see where they should be without a mark. Man, I do not. I don't even understand how to do cryptic crosswords. Man, I'm literally just learning about what this is supposed to do. So it's yeah. It contains a definition. Former lover can court no more. Okay. Oh, I see. We don't actually know what the definition is in advance, but now we see this kind of thing, and then there's a subsidiary indicator that helps with it. So it's like former lover could be X, and is it cat for X kin? Okay, I see. All right. So it's so it's that a subset of the word. Man, I'm yeah. It's that a subset of the clue is this definition, and it tells you the number of letters in each. So there's a 4-word. All right, man. I really just, like I said, never tried these. The writers tries penning papers of merit. So this subset happens to be of merit, and then we had said the writers twice. The writers twice. Oh my god. I'm containing the word press. Man. Alright, so lady has heart stolen, so it's like lady without the middle of it, so LY, and arch highest ranking. Oh my god, I would be completely terrible at these. That's okay. I don't need to solve these in a screencast. I just need to analyze the data. Now I wonder on the puzzle date. We have our times. We have puzzles. We have the date. We can look at changes over time. I'll tell you a couple things that interest me here. One is, where does the definition appear in the clue? So notice that here, like country parrot seen round city. Oh, oops. Well, here, like acquisitive chap, as we see it, acquisitive is the definition, and then sagging is here. So sometimes it occurs in the middle, sometimes it occurs at the beginning, sometimes it occurs at the end. Where the definition is within the clue is one interesting thing we can quantify. Excuse me. And yeah, I'm going to take a look at that. I'm also wondering, thinking about trends over time in stuff like we know the number of words and letters. Okay. I'm gonna process this a little bit. We might do some kind of yeah. See, we know we know this is 5 letters, and it becomes, I don't even know what. I have no idea what a crawl. I have no idea. I would do very poorly at these cryptic crosswords, but yeah, we can ask questions of trends over time. All right, I've got some. All right, so I've got some ideas of things I might want to analyze. Let's get to it. So I'm gonna start just with the times data. I'm going to select not the row. I'm also going to look at the difference. Actually, that's what one thing I'm going to do is, oh, I see. I already have the source, so I can just bind rows, choose data. Row ID, it's row ID. All right, let's get going. All right, so now we actually have the all the clues combined, and some of them will be from Big Dave 44. Some of them will be from the times. We can start to ask questions, for example, about them. Now I want to know things like when are the dates that we have? We have puzzle date, geom. We can start with nope, I meant histogram. be a little big to do a histogram. Let's count puzzle date. Let's actually do date is going to be, let's see. Yeah, okay, this is fine. Okay, so we have 10 plus years of puzzles. Let's count it a bit differently. Let's count this as floor date. Let's count this as floor date of puzzle date with by month. And now then do puzzle date n fill equals source. I meant to do geom call. And we can ask a question like, what are these by month? I just want to start with this with some questions like, okay. Though I didn't think I was doing anything so intense, but I got a bomb. Let's hope something got saved. Restarting. Okay. No, that's not, this isn't right. Let's see. One moment, please. Where's my R project? Oh, something's sluggish about my computer today. Oh, I'm running Docker in the background. Okay, let's go ahead and quit that. That probably doesn't help. Exciting, right? Watch me restart. Even more exciting than watching me puzzle over those cryptograms is watching me try and restart RStudio. It's what you tune in for. All right, here we go. I'm also, I realize I'm a little out of practice. I can do library gplot, library scales, theme set, theme light. And let's load in the data. And library lubricate. Here we go. Now we have it by month. Let's do it by quarter instead. It's a little too hasty as these go. Okay. And yeah, now we can start asking questions about like change over time. And it looks like, yeah, we only have the times for a small period of time in Big Dave, whatever this data set is, ran for more than for more than 10 years. Okay, so we get a we could add a couple other bits of information. We could add year to the of puzzle date, and that would make some other analyses easier. Okay, I'm going to add a couple more things of processing. One is definition, position. So what that's going to be is string, what is it called? It's now I just need to remember string locate. I think it is of within the clue the definition, and just in case there's some kind of regex thing, I'm going to say fixed of the definition. And I'm going to do this only for a few, and let's see what the definition position is. Yeah, so the it looks like it ends up being a matrix. So I need to remind myself, all right, so if I do string locate, so the way that this works, if I say hello world and I look for WOR, It gives me a start and an end. I only want the start. I can deal with the end. I can always deal with the end separately, and we'll do so. And now we can say clues, definition, position here. So we can say like acquisitive. This one started with the definition. This one actually ended with the definition. So I might want to say like to have this more like a percent, not like position 1, position 28, position 1, position 16, but more like a percentage such that this should actually be like, what if this was 0 and this were 1? That is, was it at the very beginning or the very end? So I'm going to call that definition. Actually, I'm going to call this definition index and this definition position. And what that is we're going to take the definition index, subtract 1, because it will be 0 for at the start, and then we're going to divide it by the string length of the clue minus the string length of the definition minus 1. What am I doing here? What I'm doing is I'm saying this has some length, and then if the clue is like we're 1, 2, 3, 4, 5, 6, 7 letters long, which this is, I'd want it to be let's see. So it's. Well, let's actually find out. I could be off by 1 error. Yeah, I've got an off by 1 error. So let's take the yeah. So this has to be like what the maximum possible value would be. So it would be the length of the clue. So it's 28. I'm kind of guessing here. Well, it's not string length. No, it is string length definition. So like sagging would be at the end. So what would be the length of the clue? Let's actually try looking at this one. So what would, I forgot about the parentheses 6. So let's separate that out. Okay. So the next thing I'm going to do is, so first, before I do that, I'm going to extract clue into 2 columns, clue and length. I could call it lengths. And it's going to be based on a regular expression of some number of characters, then something in parentheses. And I'll wrap these in a in capturing groups. Extract is fantastic for this. Here, see, now I've got inquisitive chap as we see it pulled out. Then it has a space and then this end, and I'm actually even going to throw in a here we go. This says this has to be the end. It has parentheses. Now I've got lengths 8, 6, 10, 4, 5, 2, 3, 4. Now I've separated this out. So now I think I might be able to do. Let's see. Include definition position. And oops, let's see. Yeah, just as minus. I need the minus 1 at the start, but I don't need the minus 1 here. I was off by 1. All right, so this would say, where is it? In a relative sense within the string. So I can actually say like, okay, this is the word sagging. If I just select clue, definition, and definition position. See, acquisitive is at the absolute start, sagging's at the end, stripping's at the start, where they should be gained is at the end, and so on. So now I've actually got this like relative scale of where was the clue, where was the definition within the clue. So the sometimes it's in the start, sometimes it's in the end. Sometimes it's kind of in the middle. Well, here, yeah, like here, foreign letter coming in is a French letter. Yeah, so there's a, and then it seemed to have occurred early. Technically occurred twice, but that works for us. Okay, so I've come up with this. Now, why did I come up with this? Because I want this clues data set. I'm a little interested in what is the distribution. I bet they tend to happen at the beginning and the end. So I bet if I said definition position, I bet you've got a spike. Wow, it's usually the very start or the very end. And now I can actually set boundary 0, bin width equals 0.05, let's say. Whoa. But I see a 0.02. See 0.02. Oh, this is only on the top 100, right? All right, try it again. Wow. Okay, so one thing I learned from this, I expected the start and the end to be more common. I didn't realize that generally the it's either at the absolute start or the absolute end, the definition. So that's a trick we just learned. So a trick for solving cryptograms, usually at the absolute start or the definition, is usually at the absolute start or absolute end. Now that doesn't solve it because we don't know how long the cryptogram is going to be. But let's do a bit of summarizing on that. So I can say, oops, I'm gonna get rid of this select. So let's say PCT start or end is mean. How often is definition position either 0 or 1? 66%. That looks more like 60%. Maybe it's some kind of maybe let's say greater than less than 0.01 or definition position. That didn't work. Definition position less than this. Greater than this. I have a bug somewhere. Why is one of these working? Why was the in working but the O? Definition position is a double. So if I did filter is NA, oh. All right, so there were some we weren't able to find. Actually, a lot. We weren't able to find the. All right, let's take a look at this. Select clue and definition. All right. One can't go. I don't understand this like. Goat cricketer. Oh, okay. It looks like the Times organizes that differently. Just states it differently than Big Dave's. Okay, so I'm gonna do yeah, I bet if I did group by source. Let's see. Summarize PCT missing. Mean is NA definition. Is NA definition position. So they both. Oh, I take it back. They both have ones missing. Okay. Yeah. Notice that some of the. All right. Now, what if I did it grouped by year? All right. It looks like the older ones are in kind of a weird shape. Here we go. And year and source. I'm figuring out which ones we're not able to match the definitions. I would do year, PCT missing, geom line, color equals source. We have some kind of. Yeah, it looks like they're both better in recent years. The better meaning like we consistent in the sense that we can find it as opposed to like here where there's like it adds a slash or something like that. Now I don't know why I didn't find this one, but okay. The all right. So we I don't have a full answer here, but we can start just with like yeah, of the ones that we did find a definition. And do this separately. Which is not random over time or across the sources, but of the ones we did find definition, now I can say summarize mean definition position. How often is it the start? Or at the end 95% of the time, and if I just said, yeah, that's another, there we go. So we can say how often is it percent start or end. So 94.6% of the time it's at the starter end. And has that been changing over time? If I did a group by year, notice the first couple years are sort of just no good. First couple years don't have any data, and then if I did year, PCT start or end, in recent years, it does look like, and I'm actually going to throw in a source. Yeah, we can see a little bit that Big Dave is slightly more likely later on to put it at the start or the end than at the than they were 10 years ago. It's like 94 to 96%. Is this even statistically significant? I am glad you asked. I can ask a question like among source equals Big Dave 44. I can ask a question like does the let's make that a column called start end, and start end is going to be this. Start end explained by year, date equals dot. Let's get a p-value out. The answer it is increasing over time. I didn't tell it it's logistic regression. I don't think it's going to make much of a difference yet. The story is Big Dave has gotten slightly more true over time for Big Dave's cryptograms, but only from 94% to 96%. Okay, so we learned a little bit about positioning of a cryptogram within the puzzle. Now I might be curious, like, what is the length of a definition? Now we're given the length of the answer, but we're not given, like, in the number of words, but we're not given the length of the definition. If we know it's at the start or at the end, that would be one of the next steps we'd want to know is how long is it. So I'd say definition length, string length definition. Stack them on top of each other. Here we go. And yeah, learn something like, okay, they're both pretty similar, and they both usually, what is that? What is the median here? It looks like it's about the same across both sources. I'm gonna pull this data point up into the data cleaning. And we'll do, let's see. I've got the definition length. I've got the group by source summarize, median length, median definition length. Haha, of course, sometimes there are, it looks like there are missing definitions. Yeah, both the same, like typically about 10 letters. Now, something I'm curious about is do longer clues indicate longer definitions? So we can do that. So the reason that's useful is that we the reason that's useful is that we actually have this we actually get as part of the clue, remember, the number of words. So we might want to know the we don't know, like, okay, so this is 8. We know this is 8 letters. We know this one's 4 words, and it turned out, here we go, let's take a look at this clue lengths definition. Clue lengths, so like we knew that this was 4 letters, so the actual put a stop to and then the answer was knock on the head. So the 5, 2, 3, 4 is describing knock on the head. As it happens, the definition was put a stop to, but here where they should be gained was actually a very it was a short answer exam, but the definition is where they should be gained, which is actually much longer. So it's noting that a short answer can lead to a long definition or vice versa. So now I'm actually curious, do longer clues indicate longer definitions? So the simplest thing to do here is to plot definition length. This is not going to be a good plot, and I'll show you why in a sec. It's just going to be a couple of points, not really like a scatter plot, not at all. Like here, let me show you what there's going to look like. It's not going to be string length answer. Yeah, it's just going to be a bunch of points. So I'm not even gonna let it finish running. So what I could do instead is count these two. And so count these two and then ggplot as a geom hex. That's actually interesting. There's some very long definitions. Okay, I'm only going to count the ones with a definite. I'm actually also going to count the ones where it did find a position. So the definition is contained inside of it. Otherwise, it's not a good and we're going to do geom hex fill equals n. This didn't work. There's some NAs here. I'm not going to do, geom hex might just be different. If I do geom tile, yeah, I actually forgot how to use geom hex. So the key is answer and definition length both hover down here. Is there any kind of correlation? Well, the way to look about that would be something like summarize core is correlation of these two. I always get an NA. Let's do, not is an A answer. So this, there is a positive correlation between the answer length and definition length, but I'm actually going to do it a little bit fancier and do it tiny bit and do a correlation test. So I did a correlation test and I tried it with a piercing correlation, and it is statistically significant. Doesn't mean it's important or a substantial size. It seems pretty low, but the confidence bound there is pretty thin. I can also try other types of correlations, a Spearman correlation, which is non-parametric. Very similar answer. So all right. So longer answers are associated with longer clues, but not by a lot. All right. Now now I actually want to know something else about these clues, which is not just the length in terms of letters, but the length in terms of words. Actually, see, this is 4 words, and the answer turned out to be 4 words too. Is that a general pattern? So the answer was 4 words, the definition turned out to be 4 words, which would be very helpful to know, because then if I saw a clue like select clue, definition, answer, if I see something like, clue lengths, if I see 5, 2, 3, 4, I might say, oh, okay, it's either the start or the end. So it's either rugby's, and it's probably long, it's like rugby's foul school leader, or it's put a stop to. So so I definitely would lean on the I definitely would aim for probably if I put a stop too, but the point is that you can sense by the number of words. So the question is that does that hold up? That if there are multiple, like, and here's another one. It's like heady mixture tequila sunrise, and the so we actually see it's two words, two words in the definition, two words in the answer. So I might want to ask a question like, does the let's pull out the n words answer, and actually that can be lengths, which is a built-in R function. I know I also use this column here of, you know what I'm gonna do. Actually, I'm gonna use the clue. Yeah, I'm gonna actually do lengths of strings. No, I'm just gonna use a count. I'm gonna do string count lengths plus plus 1. The idea is that I just count the number of commas in here and then add 1. It's like one word, 4 words, and then this one has 2 words. And then let's do n words definition. So again, it's really helpful to see what actually was definition, and I'll actually keep it simple. I won't do anything tricky. I'll just do count the spaces. So this is one word, but the definition has 5 words. So now I can take this and let's do the correlation of n words answer with n words definition, and let's filter for not is in a and the answer is there is a correlation, but it's not any stronger. I can do this with core test. Oops. And yes, statistically significant, but it's not that strong. And as core equals core of. So look at the overall correlation, and yeah. So there's a weak. Where is it? Let me see the. Not by a lot. I'm just gonna take, the reason I went up to this code is I wanted to include these in the cleaning, n words answer, n words definition, and that way it just makes this later steps kind of easier. Same with whether looking at number of letters or number of words. Very weak correlation between, one moment. Yeah, very weak definition correlation between the number of words and the answer of the number of words in the definition. We could visualize that. I think we don't have to. All right. So that was some examination of the clues. Now, if I were really clever, I'd want to train like a deep learning model to solve these cryptograms. I'm not remotely that clever. I don't know how. I wouldn't know how to do that. So the here we go. I'm just gonna think for a second about what else might we want to know. Okay, I might want to know how have they been changing over time in other ways. So I'll ask a couple questions about that. One is group by year and source, summarize. I do filter, not is in a answer, not is in a length. That doesn't lose much, but I don't understand. And puzzles is n. Okay, but most of all, what I want to know is PCT is, let's see, average n words answer, mean n words answer, average n words definition, mean n words definition. Mean is not perfect here, and but I'll do NA. Yeah, I remember the definition. Sometimes it was missing on some of the earlier ones. Only going to use ones that had at least 1,000 clues that year. And now I can look at something like year, average n words, answer, geom line, color equals source. Not a great giant trend there. I can keep it on the 0 and say like I can do just average number of words in the answer. How about average number of words in the definition? So if you're going to do by year source, just breaking this out a little bit. Seem to be a lot of trends that exist but are quite weak in the data. So they, this is kind of how we look for tricks. If we were like trying to just give general advice, not necessarily build a machine that would solve these puzzles itself, but like give insight to someone solving them. We'd be looking for we're looking for trends, looking for these tend to be long, these tend to be short, and that's kind of what we're pulling out here. Which were n words definition. That one's a funky one. See, Big Dave's been a little bit odd. This could be I say n puzzles, it's really n clues. You know, it's not the small number of data. Huh. So at least it's not that small. Oh, you know, it is probably that small because it's probably that most of the yeah, there was a lot of missing data back here. So the n puzzles, and first I should say n clues definitions. Some not is in a in word definitions. And clues definitions. This is just how many clues have a definition. Okay, so that early data was gone. There is a trend that Big Dave has been using shorter, so let's write this down. Big Dave been using shorter words over time. So I'm using a mean when it's just like 1, 2, 3, and it keeps going. I might have wanted to use like a different shape, but I'm not so sure that it's gonna matter. By different shape, I mean like a log normal or something like that. I think it probably just doesn't like a geometric mean. Probably doesn't matter that much because I can look at the original data and here we go. N words. N words definition. So most of them are like 1, 2, and yes, some of them could be a lot higher, but honestly they're so rare that I bet in terms of like the average versus the geometric mean, it doesn't make a tremendous difference. So we're probably mostly just saying like it's intuitive to say average number of words. So the Big Dave is using shorter. I say shorter words, shorter answer. Wait, nope, shorter definitions over time. So that is like the definition is a little more likely to be just one word picked out again from the start or the end. So we have kind of two tricks that we've pulled out in terms of here we go. Yeah, I'm actually gonna bring this in. I'm gonna say piece, let's see. I'm gonna bring this in. And I'm only gonna include ones where found the, I can skip that part, but I'm just noting that it is a little percent starter end. Oh, right. There's a whole thing where NA, I forgot about is this true that, wow, NA in these is not even NA, it's just, huh. Okay. I'm going to do not is an A definition. No, I'm going to do the subset not is an A definition position. And actually that is a hassle, so I'm just going to do equals 0 or definition position equals 1 and ARM equals true. Ooh, all right, and now I've got percent starter end, and now I've got number of words in the answer, and then I've got number of words in the definition. The words in the answer doesn't really matter if it has a trend because we already have it. Remember, the answer is the thing that we give it that it gives in the clue. All right, whew. So then I'll say percentage of time at start or end. Remember, I already have I already am getting this. I created this graph earlier, but I'm putting these all in the same place. So Big Dave has been getting slightly more likely to be, as well as slightly more likely to be at beginning or end. I don't know what to do about that spike. But what it really tells me about Big Dave is that it might be these puzzles might be getting a little bit easier over time. I generally would think of like ones that tend to be at the start or the end, and ones that are one word is like as a relatively easier one. It's sort of, I think, just like that gives one clue. Maybe it's been getting a little bit easier over time. All right, I've got a couple thoughts. One is, I bet there are words that appear a lot in these clues. So let's do text analysis. I bet in and inside are some really common like supplementary information because they seem to they allow or at the start of. So we're gonna have some prepositions, I'm sure, but and like maybe ands or and thes. But I think we're gonna get a couple other interesting things. So I'm gonna do just a head 100, and I'm gonna use some tidy text in our last 12 minutes together. So I'm gonna do unnest tokens clue into words. And I just do the top 100 to be faster and say what are the most common words used in clue. So to, a, in, and. Not terribly exciting. A lot of these what we call stop or what we call stop words. So these are only in the top 100. Let's try the top 500. I'm sure it's not going to change a lot. And let's try the top. I'm doing these slowly to see just how to not overwhelm it with too much data. All right, let's take a look at this. Oh, and I'll get rid of the count. All right, so I was right about the most common word being in. I think it just makes sense in terms of cryptic crosswords. Is that like this is in a word, but of course it's not terribly exciting. It's not uninteresting. It's more common. In and of are more commonly be in the English language, where the and are the most common words. So this is different than an atypical frequency of words. But I'm going to anti-join this with our stop word set and find out what are the words that are common. Okay, so for example, French is not on our list of stop words. I'm just gonna I don't know why we include any that are NA, but time that's left French round its initially city drink English. French and English pop up here. I'm going to do a quick graph. I love this kind of graph where I just like put it on a bar plot. I like and when we say like things that aren't stop words, but are common in cryptic crosswords, we're seeing a set of like, so time is actually is just a, I often see it as a common word, and in a sense that doesn't quite make it on the stop words list, but and that's might not be on just yeah, it's got a goofy it's got a goofy apostrophe. I'm just gonna throw into the cleaning step, you know, it's like a Unicode something apostrophe. I don't remember a way to like standardize this, but I am gonna throw into the cleaning set a step where I say clue equals string replace clue this with just a regular apostrophe. And then let's try this again. Yeah, so that's and it's are gone. Okay, so one thing I wonder about French and English, like there's kind of a signature here. I wonder, are they different between, are the words that that cryptic crossword used in cryptic crosswords different between the two sources? So that's a good time for the tidy LO tidy log odds package by I know it's by my co-author Julia Silge, and the and let's try, yeah, what we can do is we say count source and word and add adjoins with stop words. Mm-hmm. And now I say, now I need to remember what the tidy yellow bind log odds. Yeah. So the trick of log odds, it says what is the set is the source, the only two sources. The feature is the word, and we have a column n. Go. Clue log odds. And what the bind function does is it puts these on a it says okay, like briefly is used 416 times in times in the times crossword, but and I don't have here how many times it's used in I don't have it when I sort, but I might if I did absolute log odds weighted. Yeah, actually, I don't know why it's not symmetrical, but the idea is it's used 416 times in the times, 376 times in Big Dave, but there are a lot more clues in Big Dave, so the percentage is just is smaller, and the key really just is that yeah, it does look like the number of times it's disproportionately often used in the times. I wonder on 1AC that sounds messed up. And ooh, I've got another reverse. I've got another smart quote here I might want to clean out. So back when I did that string replace, maybe I just remove both, replace both of those. Oops, I didn't rerun. The key is that I can find what words are most specific to one and not the other. And yeah, so like so English is a unusually weighted in one direction. I can group by source, top and 16 by log odds weighted. This is a classic graph where I say I want to show group the words most specific to each. And we say log odds weighted word source to ask a question like, what is the... All right, one thing I learned from this is that Big Dave accidentally lets like, oh, you know, I bet these are things that like, let's take a look at those. I wonder if Big Dave is mixing in references to other clues, because we've got these clue numbers. And if so, that gives me one more interesting thing to ask. So clue, it looks like the times doesn't do that, but if I said like clue, string detect clue with 1AC, that's neat. Look, like 1AC and 4, you'll find it in Dartboard. So yeah, there's actually like, it'll sometimes refer to other other clues in the cryptic crossword. Yeah, like, I guess like a regular crossword. All right, so then so that happens in Big Dave and on the times. And now I can ask a question like, let's see, how would I pull that out? It's a number and then sometimes some number of letters. If I just assume that a number, then some number of letters, then a word boundary. So if let me filter down just for, so source equals Big Dave 44. If I say mutate clue references is string count. Now I'm going to see if I can get this right. It'll be a number, then one or more lowercase letters, 0 or more really, could just be a regular number. And then I think it's // B means a word. I think B means a word boundary, but let me check that. Select clue references. No, it's... I have a This // D is supposed to be a digit. 1, 0 to 9. But it's string count clue. Oh my goodness. Yeah. All right. All right, yeah. So, notice they're using other clues. Now, some of them I'm not always sure. Some of them aren't quite right. So because you can see like 10:59:59, it thinks that these are 3 references, which they aren't. But what 8:19, see, it's referring to other ones, but not all of them are. That's okay. I think we not 7 you'd pay to see. So, yeah, that's fine. The point just is that we can now ask a question like filter just for Big Dave, group it by year, summarize percent reference, how many reference another clue, and filter not as an A. Haha, there is a trend. Okay, and I'm going to tidy this up. Percent that reference another clue. And I'm not just going to do, and I'm actually going to do it on both sources. All right, I don't know that these are real. Maybe they are, but yeah. But the key just is we can say all right, the Big Dave puzzles have been getting used to cross-reference clues more often than they do now. All right, so so we drew kind of 3 conclusions here. One is, and notice that the text analysis really got us there because I was wondering what the heck is 1AC, but this kind of or 29 or 11A, and this helps us see, okay, so it's like it's referring to other clues, and that gave us an idea for another analysis. So yeah, overall, what did we learn? We learned that we did a bunch of cleaning, including extracting out the clues and the lengths to separate them. We realized that where the definition in the clue it could be a useful clue. It could be useful like way to solve the puzzle. We noticed it almost always at the start or the end. In fact, about 95% of the time, and we saw that was changing over time. No, this is a percent missing. This is changing over. Is more a little bit more. It's changing over time, but again, not by a lot, but statistically significantly so. And yeah, we saw that they're getting a little bit more like, especially for big day, which is going for 10 years, a little more likely at the start and the end, a little more a little bit shorter, like going from over 2 words on average to under 2 words on average, and and slightly less likely to reference another clue. Maybe all that works out to easier crosswords. But again, these are just the things I can see in 1 hour. Okay, that's it. For this, I'm going to go ahead and commit this to GitHub, so you can you can take a look at the code. The link is in the description, and yeah, I hope you had fun. I certainly did. I'll see you next week.